Welcome to today's podcast. In today's session, we have with us an expert from a field related to batteries. Ramesh Natarajan, a veteran with over 42 years of hands-on battery industry experience, will be asking our esteemed guest a host of technical questions. Enjoy the session.
Hello everybody. In today's episode, I'll be discussing about chargers for formation of battery plates, the chargers used for charging of batteries, and the equipments for battery testing. I have with me Mr. Girish Adkar, who has worked for 25 years as a technocrat in Adore Digatron, handling battery charging and testing, and offering solutions to battery manufacturers in India, Southeast Asia, Middle East, and Africa. He has traveled extensively for technical marketing and to provide solutions in the area of battery charging and testing. He is currently associated with CMW Technologies Germany as a consultant supporting their business expansion in India and Southeast Asia. Welcome Girish, and I have a few questions for you on battery chargers and testing equipments.
Good afternoon, Mr. Ramesh. Thank you so much for inviting me to this podcast. It's been really interesting since the days you have started your new journey with the podcast and a lot of writing about new battery books. And I've seen many people very much interested in what you're doing, the new things nowadays. I'm pleased to be part of your podcast, and I believe I'll be able to give you a fair amount of information that usually is required very much amongst the manufacturers.
Yeah, thank you Girish for joining, and the first question that I have for you is, what is the major factor which a manufacturer or user must specify before buying a charger?
Well, this is a very broad question, and a battery manufacturer, when he sets out to set up a battery factory, first needs to tell us what exactly he is looking for, the application, what side of application he is looking for, whether he wants to manufacture the batteries for OEs or for aftermarket, what type of batteries are being produced, and what is the volume, what is the formation process. Is it something to do with the plate charging, or the recent times is the green plate charging, and how does he cool the batteries during the formation. These are some things which is primarily required to understand what this battery factory is going to do all about, and what sort of solutions we will be able to give them. This is a starting point. We always discussed, or we set of questionnaire for the manufacturer to tell us more about what he wants to do.
Basically, you want to know whether he wants to use it for battery plate charging, or for a flooded electrolyte battery, or for a VRLA battery, or whether it's going to be a constant current charger or a constant voltage charger, or all these things, is it?
Yes, because basically a charger is just a device that you convert the AC energy into the DC energy that is going to be fed into the batteries. And in doing so, there are a lot of factors that is involved, be it efficiency, be it controlled current, be it gassing voltage, be it the temperature that is going to be building up, be it the pressure, and so many things. That is technical parameters of the batteries. And to do so, the charger these days are more intelligent, more smart enough to be interfaced. We have a lot of sensors that can be interfaced to the chargers, and these have to be interfaced in such a way that it gives a proper solution for application that is intended.
So basically, you have chargers in different classification, different types, and you want to know what exactly the manufacturer needs.
Exactly, that's right. So when we say the classification of chargers, for example, if we do with a dry charge, we have the plate charging. This is simple. We just put an ampere hour into the batteries with a rectifier for a certain amount of time, and we see to ampere hour that is going into the batteries or into the plates. So this is a simple charging. But when it comes to battery charging, when I going to put it into a box, that is where all this automation, we have to take care more about the batteries, like how does it increase the temperature when you put a certain amount of current, How do you monitor this temperature? What do you do next when the temperature rises? So how does the battery charger comes to know? So the efficiency of the battery charger, the way it is designed to handle such kind of things. In case of a plate charger, it is quite simple, while in case of battery charging, there are a lot of methods that can be employed to get an efficient and an optimum charge. And that is why we call the classification as a plate charger. We call a classification of a charger with a water-cooled temperature controlled charging. For small battery cases, we employ this small current chargers. For a very high capacity battery chargers like the traction batteries, there is a way of doing things like an acid circulation method of chargers, wherein there is a lot of extension interfaces between the charger as well as the acid circulation systems. So these are various classifications that we have placed so that it helps in optimum way the chargers are utilized to get the best out of the chargers and best processes.
See, in earlier days, things used to be simpler. People used to form the battery plates and then do the charging. So there was a formation charger and there was a battery charger where temperatures were not going up so much as it goes now with the green plates, where the formation process is totally eliminated and people are directly using the pasted plates or the filled plates after pickling in the assembly of the battery and directly charging the battery in the small containers where the electrolyte is limited, and so the temperature goes up. So I understand when you say that it is very important for the battery manufacturer to keep you informed of whether he is going to form the plates and make the battery and charge it, or whether he is going to directly use the green plates where probably you can also give a temperature sensing and everything along with your charger.
Yeah, that's exactly right what we want to start with. So in case of green plate formation, as soon as you pour the acid and then you start your waiting period, you already know the temperature is already rising fast, and now you have little scope to put more current into the battery, because everyone wants to finish the formation fast. But then when you have this small battery and that too caged into a battery box, you cannot put as much current as you intend to in the initial stages. I'm not sure whether it is because of the internal resistance being high at the start of the charging or the formation. For whatever reasons, if you put more current, we have seen that the charger voltage is going very high initially for the first few minutes, and then slightly comes down and then takes a fairly equal rate of rise of voltage in the next of formation. So all these kinds of stuff can be well captured if we use a computer as dedicated software. So it captures the temperature, it can capture the voltage, it can capture the current, it can capture the ampere hour and watt hour. So we get a sort of a data trend in what happens at which stage and what is more appropriate. And since a large battery manufacturer has modeled it out earlier, he now knows what needs to be done in this initial, in the middle or the end phases. So, but for the smaller battery manufacturer, it becomes more important that he understands these things, and then we provide them a charger with a facility that he can utilize it properly.
So then the use of a computer and dedicated software becomes more important when he's doing a green plate charging rather than when he's doing the formation. Right?
Yes, that is absolutely right. So when you start with the green plate formation, the use of a computer, a dedicated software for battery formation, you enable him to collect as many data as possible. In return, he gets so much information into it that he tends to do it correctly. An optimum and an efficient charging happens. You have all the information in your factory. Even after the battery goes out, you have the batch, you know which batch, what happened, and
how was the charging
has happened, what all happened. So you have the trend in fact with you. So it helps, and it also helps in monitoring the process efficiently. You can handle the production efficiently. So one man can do everything gets recorded on the computer. You no need to find out, record many things. Everything is automated.
This is from the software point of view and the charge output from the charger. What are the other important parameters of charging that a battery manufacturer should be aware about to to make a wise choice of the charger, because there are now a lot of charger manufacturers in the field, and I have seen that many a times people do not care much about efficiency of a charger or the ripple, the harmonics, and all these other factors also, which are quite important. So are there any factors other than this, the 2-3 which I mentioned, which are also very important, and which especially the small battery manufacturer who does not understand much in electronics and much about chargers, he should be aware of, which you would like to enlighten them about this?
Yeah, this is, as you rightly pointed out, this is one such subject that most battery manufacturers, even the big ones, tend to ignore. As we discussed earlier, and as I pointed it out, it's more important that we transform the AC energy that is we draw from the grid and put it into the battery. Now, in doing so, as I have seen in many battery factories, the amount of energy, the energy cost is almost 50% coming in from formation.
Yes, charging section.
Charging section. So when the charging is the most important, most expensive part of the entire battery factory, it is more important that you select the right charger, you understand how is the efficiency and how is the ripple, what sort of harmonics are being pushed into the batteries while charging. So these set of parameters, which we call poor quality of power that is injected because of use of chargers, especially the thyristor chargers, or even for this case the IGBT chargers, recent IGBT chargers. The battery manufacturers know very little about these factors.
So which is better, thyristor, the IGBT, or the transformer types which were there earlier?
In fact, the IGBTs are better, but in fact it depends on the economy, it depends on the budget, it depends on the volume what the battery manufacturer uses. From the technical point of view, of course, the IGBT or the high frequency switching chargers are the best. They are having IEEE standards. They follow the IEEE 519. So the ripple is very less. You have less than 5% ripple when you're charging. Your efficiency is above 90%. Your power factor is better than 0.95 lag, or even sometimes 0.99 lag. But then when doing so, the bigger battery manufacturer knows these importance. As I said, 50% of the energy cost, 50% of your time, 50% of everything is spent in charging section. So the bigger manufacturers understand these things, and they do take care of all this design of the chargers. They specifically go into the design of the chargers to find out if the chargers are efficient enough. They give better efficiency, they have less harmonics, they have less ripple, so that the optimum energy that is required to be sourced from the grid into the battery is optimum. We call it an optimum charge, as is required, no more, no less.
Other than this, now since you mentioned about large manufacturers, how do large scale battery manufacturers tend to stress on what other points do they stress more in a charger compared to a small scale manufacturer? I mean, what are the points which a small scale manufacturer may oversee? And because the large scale manufacturers definitely have people who are not only experts in batteries, they have a section where you will have a lot of people from the electrical engineering department or the electronics department who understand chargers also, and who are in the purchase department or the technical department, who must be specifying in a better manner compared to a entrepreneur running a small scale or a medium scale industry. How are they different, or what do they demand from a charger manufacturer which a normal small scale manufacturer may not be demanding?
As I've come across, as we mentioned, the small scale battery manufacturers have less manpower who are really trained. But I would also point out one thing, that the entrepreneurs, the small scale battery manufacturers are very smart.
They're more money conscious.
They are more money conscious. They are more demanding, in fact.
Good.
they in fact go into the penny details of each and everything they are spending. So they know what they are buying. Sometimes, yes, what they overlook or what we tell them is they have a set of batteries. Means they manufacture, again, it starts with the first
range.
questions. We don't know what they are manufacturing batteries for. They have a wide range, because today a small scale manufacturer cannot just make one model of battery or one area or one segment of batteries.
Yes.
He has to manufacture batteries depending on where the market is, depending on the situation where he can push batteries. So for him, there is a whole gamut in front of him, what type of batteries he need to do. And that's where he tends to use a single charger. For example, I would say, suppose he has a 100 ampere charger. Now he would not mind to use a 100 ampere charger to charge motorcycle batteries or a small UPS batteries. He tends to do it.
Yes.
Now what in this situation, what happens is he knows that he has a 100 ampere charger, but the small UPS and the small motorcycle batteries, you need hardly 1 or 2 ampere current, less than 5 ampere. In fact, the highest current in the discharge mode is around 2.5 amps. So you would not go beyond that. So when he has a 100 ampere charger or a 50 ampere charger and he has to use it less than 5% of that capacity, it's a total waste of energy in between. Of course, all chargers do have a drop in energy inside the charger. It has a heat loss. So there is a lot of heat loss. The heat loss or the efficiency is lost inside the chargers more than what he is actually putting up into the batteries. So what he tends to do is, he tends to now think about, okay, what can I do best? So he now tends to put all the parallel charging. He puts more batteries in parallel than in series string. Usually we recommend a series charging string as the right way to a battery charging, so that the right amount of ampere hour is going into the battery. But then there is no choice for him, that he cannot spend so much time that he does a series charging for say 24 or 48 hours, get one set of 20 batteries and then wait for the next set of 20 or 40 batteries. So he straight away puts parallel charging into effect. And this is where there is a lot of difference between how the bigger manufacturer and the small manufacturer operates. Both of them know that they have a bigger charger, or their charger is not rated right for what the right kind of battery they want to charge. But there is no choice for the smaller battery manufacturer. Then this where we come into the picture and we try to size them to what side of batteries they produce, and then for which kind of batteries, which kind of chargers, what rating of chargers would be the most suitable for them. We know that they may tend to make the changes in the battery models, and even with such a change short term, still the battery would be very close to what they want to do.
So basically what you mean to say is the small manufacturers, I mean, they are aware that they have to look at efficiency and various things, but when it comes to actual usage, there is a possibility that they are bypassing everything and using a 100 amps charger for charging a battery at 5 amps or 10 amps, and that is where they end up losing money.
They end up losing money this way. Even we have come across situations wherein they have a quick order and the order quantity is very small. So for example, a charger is designed for 360 volts or a 400 volts or a 300 volts. So in case of wet formation or a box formation, what you call, you have 20 batteries connected in series. But usually the small battery manufacturer don't have 20 batteries at a time. He is either short of some batteries. So many of them come back to us and ask whether we can use one battery or a 5 battery to charge at this point of
they
time.
must be charging a 72 volt, maybe 6 batteries in a charger meant for 360 volts. So that is also
that's also harmful,
not
recommended. Like he tends to lose, he will have a very poor power factor if he is using a SCR based charger, because SCR based chargers in a way are economic. They're very sturdy, but they're economic, but they tend to have a very poor efficiency and poor power factor when using such kind of low voltage charging. So instead
you should be using it close to the full capacity, like 360 volts should be used as much as possible, closer to 360, and the current also you should be closer to 100.
Unfortunately, in this is something called a non-linear load. Battery formation is something called a non-linear load. We have the other divisions, for example, variable frequency drive for motors and other things.
Yes,
they are standard. Okay. In case of battery formation, energy that is converted from AC to DC, the voltage conversion that happens, it's not linear in the sense that the voltage does not tend to remain the same. As you put more energy or more current into the battery, the voltage keeps increasing.
Yes.
So when you start the formation, for example, a green plate formation, you would find that the voltage is quite close to 300 or 360 or the maximum, because at that point of time the internal resistance is a bit high. So most of the rectifier voltage is going into the internal resistance, that's all. But when that subsides, as you go further, you can see there is a dip in the voltage. The voltage comes down. So voltage is not really in your hands. It depends on the chemistry of the battery.
Yes.
So, and this is where the new technology of MOSFETs or high frequency chargers like the IGBT is more useful. That you operate it at any voltage, you would still get a better efficiency, you would still get a better power factor, you would still get a better harmonics.
Okay.
With IGBT based chargers. With the thyristor based chargers, unfortunately, these things happen that you will end up losing money, or it's not an efficient kind of charging. Your power factor will be poor.
But it is definitely better to be closer to that 360 rather than putting 72 volt.
Yes.
Right?
Yes.
That is what I mean. So you should operate to the maximum voltage and the maximum current of the charger.
Yes.
Once you have a charger of a certain voltage and a capacity.
Yes. So in this situation, this is where the first question we started with, we want to know the classification, or even before that, what the chargers are supposed to do, what kind of batteries, how many batteries he is going to put. These are set of questions we start with. So we guide them.
So this is where the difference between the small manufacturer and the big manufacturer is mostly.
Yes, and this is where we come into the picture, and then we advise him properly that, okay, in his gamut of business with varied segments he's catering to, so what kind of charges is better suited for him, and what rating, voltage and current and so on, and how many such chargers is also a question. Like, so how many to be charged? How many sets of chargers should be working in a factory? Because in many cases, even you have a thyristor chargers, one cabinet is of different vector combination, other chargers of vector combinations are different. All these things are coming into the manufacturing and design of chargers to get you the best out of the power factors and so many other stuff like harmonics. So we come in and guide them to make the best use of the charger designs.
Okay. Now, this is mostly in the case of, now you were talking of voltage, current, but temperature also plays a major part in battery, especially in the case of VRLA batteries. So are there options in charger that can monitor the temperature and help reduce the temperature or control the charging based on temperature?
Yes, of course. This is a very complicated way of interfacing the temperature control. And to my knowledge, Digatron has the best topology or the interfaces available in the market. Lot of research work has been done, of course with the help of the manufacturers, in formulating the right way of temperature control. And herein a lot of temperature sensors are put onto the batteries, and also the cooling medium. For example, if the batteries are done in a water bath, the temperature of the water bath is also measured with respect to the temperature of the surface temperature of the batteries.
Delta temperature.
If you have an option that you can measure the electrolyte temperature, you are still more close to your actual control of the batteries. In the now modern days, the batteries are mostly sealed, maintenance free. So you measure the surface temperature.
Terminals or the surface of the container?
Temperature on the top lid.
Okay.
And then we can find out the delta temperature between the surface and the water. So you come to know, you have to understand.
Some approximation has to be done.
Yeah. You have to understand the gradient that comes, and this is where all this stuff like temperature control, then the way you can control, the way that you can keep the gradient and all those things comes into the picture. And this is where computer operated programmable controllers with interfaces with cooling, temperature sensors becomes very important, and it definitely helps to give you a very optimum charge into your batteries.
So that means you are able to check the battery condition during the course of the formation at various stages of the formation.
Yes, as various stages we understand what's the temperature, And added to it, there are even examples wherein in certain kind people or companies do measure the intermediate voltages of each and every batteries while doing the formation. So specifically customized design data loggers are also being used during the course of the formation. So that gives even more clear picture, like, okay, your specific gravity inside the battery cannot be found out easily in each and every battery. So that appears in the form of voltage. So you understand what voltage was achieved at what point and what was the temperature at that point.
Okay.
And how much ampere hour had gone and at what point of time. So you have all the data now. But then when you want to add a data logger, when you want to add temperature control and measure all these things, of course your total budget becomes much bigger. And herein maybe some cases the manufacturers tends to set up a pilot scale first of all.
Yes.
To understand
yes.
before they go into the large scale manufacturing, where they don't spend much in the R&D. So that is one way the smaller manufacturers can do initially to cope up with what the bigger manufacturers do, and this will help them a lot.
But then when so many factors are involved and so many things are involved, and the charger is becoming more and more complicated, it's just not converting a AC to DC and giving it a charge. So do you think the charger manufacturer has got a charger which is now very sophisticated, and the battery manufacturer will have to go in for an AMC or something like that? Or are these things so rugged and so good that they don't require an AMC and it's possible to use the charger without having a maintenance contract or without involving the charger manufacturer?
Yeah, it all boils down the way the battery manufacturer feels comfortable. As a designer or as a supplier or as a manufacturer of the battery charging, of course, these are designed rugged. In the course of time, what happens is, we have practically come across is, there is a lot of experimentation even with the bigger battery manufacturers. They tend to experiment a lot in different ways because their OEs are pushing the battery manufacturers to deliver something always different, something is always coming up.
Yes.
So in such cases, what happens is, the charger manufacturers, even myself, have interacted with battery majors, R&D departments while formulating the charging topologies. And then we have spent a lot of time sitting at the battery manufacturers shop floor analyzing many things like this. So it definitely makes sense. The battery manufacturers give some sort of an annual maintenance charge or annual maintenance contract with the charger manufacturers. It will definitely help them improve the way they are doing it.
Because in that case, anything more in the software also, you can go on updating or upgrading and adding. And
in fact, I remember while I was still in Adore Decathlon, our maintenance contract used to be like, we used to promise them that the chargers would be working well above 99% of the time.
Okay.
So we had something called, we draw ourselves to be most like a prognostics than more of a diagnostics. Like we used to tell them, okay, you're going to charger, or you have spent so much time using these chargers and it's now time to check the periodic maintenance. So there was a program also that we go to.
That is for the downtime.
Downtime, that okay.
That there will be no downtime. But once you have an EMC, is it also possible for you to promise them that you are using the charger most efficiently and you are getting so much? The wastage is less or something like that. Also, is possible.
It is possible, but there is
to
also
build into the
of
software.
It is really possible to build into software. I remember a battery factory wherein Decathlon had to introduce load management.
That is what I was coming
load
to.
management is something that you have specifically in India when we have a shortage of power, specifically in the summer seasons. In the earlier days, we used to see that in the evenings there was a load shedding. The battery factories were asked to shut down certain operations, and only the formation section used to operate, or some other sections used to operate, so that you cannot stop those conditions.
Yes.
So in such conditions where you have shortage of power, the charger, the computer and the software, they are integrated with the load management system of the grid, of the substation of the factory.
Yes.
So when there is a the requirement of shutdown, the
current comes down.
yes, the chargers are designed to operate at a optimum level of current. The charging is still going on at a lower current.
Lower current, yes.
So the charger is smart enough to be integrated with the grid as well. And such kind of projects have been taken up as well.
Okay.
But then, as you say, these are things that this is a budget. You call for a budget and then.
But once you do
monitor all
some
those
software,
things.
any company does some software for a big company, and they've already invested and done it. It's very easy for them to introduce it for everybody, because finally the nation benefits also.
Yes, that's why the automation is important, that it finally benefits everyone.
Everyone, and more so with the EVs coming in, the demand for power will go up, and so unless we save power, how are we going to run the EVs?
That's exactly why this automation and new technology is very important.
Now, is it also possible to find out the quality of the battery?
Yes, after the formation, as you rightly pointed out, it is more important that you understand whether your battery is fully charged and so on. This is where we have this end-of-line testing machines, which are basically developed in the finishing lines of after the formation, that helps to understand whether the batteries are really properly charged. You have a set of voltages. When you discharge, you discharge the batteries at a high rate, and look for the terminal voltages, the end voltages at certain rates of time. For example, say after 4 seconds or after 10 seconds, and then you can understand the rate of discharge and whether the battery is fully charged or fully pumped up. So we also can see the voltage of OCV as well as the terminal voltage at end of 4 seconds or 10 seconds, find out the gradient, the slope. And with this, it also is important that you understand how quick the battery is discharging when subjected to a certain discharge. So this gives us a clear picture of how good or how bad the batteries are. In fact, even in certain cases, when there are problems internally, I don't want to specifically mention, but then I have heard of sometimes some separators or something wrong has happened inside, or something has gone assembled wrong inside.
Okay.
But still the batteries are charged and it shows up the OCVs. Even in such cases, when you subject these kind of batteries on your finishing lines, you ensure that your whatever batteries are getting tested goes out past 100% fit into the market, so that you can reduce your warranty cost. And this is where these end-of-line testing machines are more important.
But this is not a part of the charger. This is a different equipment.
This is a different equipment. This comes along with a quality test. This is basically quality testing equipment.
So this is a battery testing equipment and online battery testing equipment.
Yes.
But this is not a part of the charger.
This is not part of the charger.
Okay. So this
But then you tend to understand, for example, after a production shift or in a month, you produce so many batteries, and then when you in the production line, you understand how many batteries have really passed and how many have failed and what the reasons are. Then you can correlate back to a charging regime, or you correlate back to whatever the reasons, assemblies and whatever it is.
Okay. Now there are, you mentioned that people buy these chargers and they use 100 amps charger for parallel charging, and sometimes they do a series parallel and all such things. Okay, according to me, this should be affecting the charger and is not good, especially at certain times. What do you say about this? Is it recommended and should it be done, or does it affect the charger?
It's not really recommended. We don't say we can recommend such kind of parallel charging, because we never know the charge that has gone into the batteries when you do a parallel charging. For the rectifier or for the charger, you program it for a certain amount of current or a certain amount of time and for a certain amount of ampere hour to be pumped inside, and charger does its work. But you connect two strings in parallel, you never know how much has gone into it. For example, you have 3 strings connected to a charger, and one string, for some reason, some link in between the two batteries has gone wrong or open. So the rest of the current and the rest of the ampere goes into the remaining two strings, and that gets more charged
yes,
than the third one. And there is no way the battery manufacturer knows that the third string is not working or it's not charged at all. This is actually a loss for the battery manufacturer rather than the charger. But then one thing is, many times we have seen the battery manufacturer do the discharge as well on the same charger with these parallel strings. Now what happens is, in most cases in India, the chargers are thyristor based, and then you operate in the discharge, and when the power fails, for a certain amount of time there is a short circuit before some switch at the output side is opened. So say for example a contactor or something opens up. Till such time there is a short circuit current that is flowing in, and the source of this short circuit current is the battery itself. So when you have 3 or 4 or more parallel strings of batteries, you have that many times short circuit current flowing into the battery, and this short circuit current, the circuit is completed through the charger. And this is where it ends up blowing up the charger, maybe some wires burn up,
quick
or
acting
contactor burn up.
fuses.
If you have quick acting fuses, as many power fluctuations or power shutdowns happen in India, specifically in the rural areas or in any places, because most of the battery manufacturers are on the outskirts of any city.
Yes.
Wherein the grid is not very good, and there is supposed to be a lot of power shutdowns inherently happening, and especially if it happens during the discharge, it takes down your high-speed fuse as well quite often, and it's very expensive. And one more thing this small manufacturers tend to do is that they buy spurious fuses available in the market, not buying the original ones. We recommend something like say Eaton or a Busman fuse or a high-speed fuse, and when it blows up, the smaller manufacturers tend to get some local ones, duplicate, which is difficult to really find out, and then that even tends to aggravate the problem. So as a small say, the parallel charging was beneficial for them, but when it starts creating problems, nuisance like fuses and discharge failures, power outages, then it reflects on the chargers. There is a lot of failures in the chargers because of misuse.
Not exactly a misuse, but because when the power went off at this time, and though he was using a parallel charging, that is how it...
But then the reason I put it this way is that it was not intended or designed.
It was not designed for a parallel charging.
It was not known that this kind of things would be used.
But is it possible to design a charger for such a parallel charging?
It is always possible, but then in the discharge, that can be taken care that if you are putting a fixed number of strings into the discharge as a parallel strings, of course you can limit the short circuit current in some
to
ways.
about 3 strings?
Whatever, it can be 3, it can be even more, it can be even 10. I have seen in Chinese chargers.
I think what is more important is the length of the cable used for the parallel string and the cross section has to be same. And they have to be tightly connected everywhere. And you have to probably, after connecting the parallel strings, you can measure the current in each string using a tongue tester or a clamp tester to ensure that all the strings are getting charged properly, equally. In which case, I think this problem may not be so much if the charger...
Then has to be a manual activity by the charger.
By
they
the
have to take their own
battery manufacturer.
They have to understand there is a
possibility of a mismatch.
And then could be some batteries are charged at 90%, some are 95, some are 100, some are 105. You never know. And those every possibilities cannot be taken care in the charger.
These are okay in case of flooded electrolyte vented type batteries, because there it's sort of you can do a slight overcharge and
but then
make up you are wasting power.
Yes, we are wasting. This is not optimum charging. Then.
It's not optimum charging.
We are not good using of efficient way of charging. We are spending more money.
Since you talked of battery testing, what are the other factors according to you which is important after a battery is formed to help understand the battery quality, and what are the other ways to monitor it other than the one tester what you mentioned? Are there more testers available online?
This is where the warehouse charging or a warehouse facility is more prominent, but I think in India it's not very easily seen somewhere. But out of India, there are warehouses where they monitor these batteries like this. They monitor the self-discharge. After 2 or 3 days or after a week, they understand what is the self-discharge, and then they monitor it and then charge it back. They also do a high rate discharge test before they deliver it to their customers, the batteries to their customers. So they also check the specific gravity, and they do an HV test. Of course, the HV test is done in the factory, not in the warehouse. So high voltage test, specific checking of specific gravity, checking of self-discharge characteristics, and finally the high voltage, high rate discharge characteristics. These are the things that is important, and this is why the end of line testing again in the warehouse solution is also important.
So actually that reduces the warranty claim also, because once the battery manufacturer gives some battery to a distributor, usually the trend is the distributor just passes it on to the user, even if it has been lying with him he may be having some batteries which have been lying with him for 6 weeks, and something which has come fresh, they mix it and give it. So actually this part,
That is
the warehouse charging
is
is something which is not very
common
in India, and I mean probably the battery manufacturers are also not insisting on it, and that's why this is going on in this manner.
This is the reason we have seen in places like Indonesia and Thailand, when batteries come from Europe or for specific reasons. For example, Ford in Thailand insists on a certain type of battery. Now when it arrives from somewhere, and the local manufacturer, the local supplier or distributors have been asked to put up charging and testing facilities to measure all these things before it is supplied to the OE. And this assumes great importance.
I think this is more important, especially when it's a cycling battery compared to an inverter battery, because in an inverter battery what happens is you connect it to a charger and it gets charged at home or in the UPS system before it's used. But when it comes to e-rickshaw batteries or any cycling battery for that matter, or batteries used for golf carts and all that, it becomes more important that all the batteries are of the similar voltages and of the same batch, same capacities, because directly they get connected to a vehicle, and right from day one the voltages vary.
This is one area I always felt that the charger manufacturers can add more, give more value to the batteries. Like there is a less amount of data monitoring or the battery monitoring. Like in the lithium pack nowadays, we have this BMS.
Yes, BMS.
Which is very common and is very important. So we don't have a BMS in lead acid packs anymore. It was not intended. It was initially, I believe, thought to be more expensive, but not always. BMS is not very much expensive these days, and you can easily have this BMS in even the lead acid packs. But the purpose could be different. You could have a different ways
and
of
actually
using
the
those
BMS
things.
for lead acid will be not very expensive, because you don't have to monitor many aspects like you monitor in the lithium ion.
In lithium, mostly the BMS, you tend to even charge or discharge the cells, individual cells, with the high frequency MOSFETs and other things. You need to balance those out. Here in this lead acid, you don't need to minutely balance all these cells or the batteries in the pack. So the nature of the BMS is very different, which can be easily configured in a different way. You can help understand how good or bad your batteries are.
Anyway, thank you, Adkar. We had a good session, I hope, and I hope you also enjoyed it. And I'm sure you've given a lot of information, and I'm sure our listeners will also like it.
Thank you so much.
Thank you very much.
Thank you so much, Mr. Ramesh. It was very pleasing, close to my heart, and having served the battery industry for so long, many questions keep coming up, many interesting things. It will always be pleasure to have such questions come up any point of time.
And
thank you so much.
I hope to come back to you with some other questions of the BMS if you develop something in the future, or maybe
we have a host of things.
CMW Technologies, and
yes.
if they do something in the future, then we'll have one more session on BMS.
Yes, in fact, CMW Tech is always working on niche areas, and there is a lot of inquiries with them for development of different kind of electronics and testing stuff. And this is where I'm going to give my expertise into CMW Tech, associate with them more, and then we are trying to build many things. Hopefully we have another time where we spend more time on BMS and other things.
Thank you.
Help our guests and other
Thank you very much.
Thank you so much.
Okay, bye.
Thank you.
We hope the Q&A session was useful and insightful. You may contact us by writing to rameshnkailad@gmail.com, rameshnkAILAD@gmail.com.